Hey everybody, it's Miss Bergman again. This time we're out in my backyard. So if I'm not on the computer, I've been out here working hard in my yard because I guess what else is there to do, right? Well, today's lesson is talking about the area of different shapes. And so I thought, what better way than to talk about the area formulas and things that I used to start helping me with this yard project. Okay, so handy tape measure here. This is my ruler. And one of the things that I had to do first was I had to figure out how much area I was working with. So area is a two-dimensional calculation, and it's usually we have a length and we have a width. And so what I did first was I had to measure the width of my area. And so when I measured this out, the width of my gate area right here is 4 feet. So when I measured this, I got 4 feet here. And then I had 3 feet over to the side of the house and another 3 feet on the other side. So my brick pathway here, my pavers that I've put down, had to be 4 feet wide and then 3 feet on each side. So my distance across is going to be a total of 11. Okay, so when I wanted to put my pavers down, the next thing I needed to know was, well, how many pavers am I going to need? And so what I did was I measured, or I looked up online how long each of these pavers are. These are 18 inches wide, and so I decided I would do 2 of those. So 18 and 18 is 36 inches. That's going to give me about 3 feet. That gives me a little bit of space to play with on the edges and in the middle. So I took the width of each of those, and I divided my full area by the width of the bricks, or the pavers, and that told me how many I was going to need, how much area these pavers would cover. Okay, one of our main words associated with area is the word cover. I'm trying to cover this area with pavers. Okay, so as I'm laying them down, I'm covering that space. So again, cover is one word that's a key word for calculating area. So when we go inside, I'm going to show you some formulas that I might have used to do this and what area really looks like with the formula chart for 6th grade. All right, let's get at it. All right, guys, we are back inside, and what you're looking at now is my lovely drawing of what I was trying to do with my yard that we were out talking about. You can see over there on the left side where it's all scribbly. That's the plan of what I was trying to do out there. So it all started with a plan, just like all of your math problems should start with a plan, right? So we know what we're doing. And then once you do your plan, you can see I've made some calculations here. If you notice my work over here, I've got a proportion. We've already talked about those this year. And here I'm multiplying, and this is actually a volume problem with 3 dimensions. We'll talk about that later. We've also got down here, this is where I was talking about, how many bricks am I going to need, how many pavers am I going to need. So here's the pavers, and how we were trying to figure out how many of those pavers I was going to need based on the amount of footage that I wanted to cover. So it looks like I wanted to cover 95 feet with these stones, okay? And then I'm also doing some bricks later on, so there's another area calculation down here. Those bricks are going to be 10 inches. So this is how we start when we have a problem like that. You have to start with some kind of plan of what you're going to do. So this is a really good life example of how we use area to figure out some of the things we're going to do. All right, so area is actually a 2-dimensional calculation. It's 2D. Now y'all have heard of 3D. This is 2D because 2-dimensional means there are 2 measurements involved. Now these measurements are not things we calculate. These are things that we actually use a ruler or a tape measure or something where we actually have to measure how long or wide or something is, okay? We talked about outside that one of the key words for area is cover. So if we're trying to cover an area, that would be a key word for that. If you've heard of an area rug, an area rug covers a certain portion of your floor. okay? We also have words like tile and carpet as keywords for area because they cover the entire floor with a tile or they cover the entire floor with carpet. So there's lots of different keywords that we could use for area, but anytime you're trying to cover a flat surface that's two-dimensional, you would be using area calculations, okay? All right, so we're gonna start off today. We talked about some quadrilaterals on our last video, so we're going to talk about some of those quadrilaterals today. So the first one we're going to talk about is a square. And the area of a square, the formula for that is side squared or S squared, all right? So we remember that this means side times side. So we could actually write that formula like that. Nobody laugh. All right, so now the way this formula came about was that we took a square, which we know from our last video has 4 equal sides that are marked by tick marks. That shows that they're all equal, okay? And so what we're gonna do is we're gonna take this side times this side. And in a square, it doesn't really matter which 2 sides you use because they're all the same, right? And so to calculate the area, we could do an area model, okay? So if this side is 3, that means we have 3 columns, and this side is 3, that means we have 3 rows, and since it's a square, both sides have to be the same, right? And so the area of the square would be what you would find in the middle here. So we would have 9 boxes. So if we came back over here and we substituted 3 for the side, this would be 3 times 3, or this would be 3 squared. Excuse me. So 3 times 3 is 3 squared, so these are the same thing. And so 9 is our answer to this question, which we found when we did the area model over here. Okay, now when we talk about the units of area, this means if this is 3 centimeters and this is 3 centimeters, then this is centimeters times centimeters. So centimeters times centimeters, just like S times S, is going to end up being centimeters squared. And so our final answer here is going to be 9 centimeters squared. So all of your units for area end up being written with a square. So this is units squared for all area problems. Units squared. Or you could also write it as units squared. It means the same thing. Okay? All right, so that is our discussion on a square. Now let's move to a rectangle, which will be our second shape today. So a rectangle has a formula for area, and that formula that you probably learned in elementary school was length times width. Now, as we get older, we're going to replace that length times width. We're really going to start talking about base and height in all of our shapes going forward, okay? All right, so in a rectangle we remember looks like this, has 2 pair of parallel sides. They're parallel and they're congruent. So that means this side equals this side, and this side equals this side. Okay, but they have different tick marks because they do not equal each other. All right, so let's say that this is the base because it's the bottom, and this is the height because it's how tall it is. Okay, all right, so if we took this rectangle and we made an area model out of it, let's just say this base is 6. That means we would have 6 columns. 1, 2, 3, 4, 5, 6. And let's say the height is 3. So we would have 3 rows. 1, 2, 3. And so if we counted the boxes in here, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our area model would give us 18 units squared on the inside. Okay, now we all know that it's much easier rather than to count all those boxes, especially when the numbers get bigger. It'd be much easier just to take the base this 6 is the base, and let's substitute it here, and let's substitute the height in for the h. So this is really 6 times 3, which would be 18, and we could do that for the length as well. 6 times 3, we still get the same answer. And remember, if this is inches and this is inches, then this is inches times inches, which would give us inches squared, which would be our final answer. So there's our square, and there's our rectangle. Pretty easy. You probably already knew how to do those from elementary. Just trying to tie the area model to the formula. Now, if you notice, all of these formulas have equal signs. These are all equations. What have we been doing for 2 or 3 weeks? We've been talking about equations. We did that because I wanted you to be able to solve an equation before you got to your area formulas. Sometimes I do things that are so smart. Okay, now we're going to move on to our third shape, and it's called a parallelogram. Remember, it's a parallelogram, not a parallelogram, okay? So the good news about parallelograms is the formula is exactly the same thing as a rectangle. So that area is base times height. Now the reason is, remember, parallelograms and rectangles are related. A parallelogram is just a leaning rectangle. So if we draw this guy with 2 leaning sides, again, he has 2 parallel and congruent sides. Whoops. Ignore that down there. Okay, so now here's our base. That makes perfectly sense, right? The base is on the bottom. But what we can't have is we can never have a leaning height. Nobody wants their height measured while they're leaning over. You would never be as tall if you were leaning, okay? So our height does not lean. No leaning heights. Okay, so that means we can't use this side and we can't use this side for the height. We need to go to the straight up and down height right here. Okay, so it has to make a right angle with the base to be the height, a straight up and down height. Now, you could find the height on the inside of this parallelogram, or you could find the height out here. If you straightened up this parallelogram to a rectangle and made this a 90-degree angle, you could also use the height out here. So you could use either one. You could use the inside or the outside. Okay, so let's say that this height is 6, and this base is 6, and this height is 3. So again, we would just substitute them in. The base is 6, the height is 3, and so if this is 6 centimeters and this is 3 centimeters, then this would be 18 centimeters squared. And that would be the answer to your parallelogram. That would be the area of that shape. Okay, so it looks a lot like the rectangle. The only thing is we have to make sure that we do not use a leaning height. It has to be the straight up and down height. Okay, we're going to do one more for today, and we are going to do, our last one is going to be a triangle, because it is also related to a rectangle. Okay, so we've got our triangle here. Try to make all this look the same. Nice pretty notes. All right, and so our formula for a triangle is A is for area, is 1/2 times the base times the height. And remember, anytime a number sits anytime these guys sit next to each other, it means multiply. So it's 1/2 times the base times the height. Okay, now there's another formula for a triangle that I actually like better because I don't have to use this fraction. Okay, but a lot of times you're going to see it written with 1/2 base times height. Okay, but you could also say base times height divided by 2, because we know that half of something is the same thing as splitting it into 2. So those formulas are exactly alike. They do the exact same thing. All right, so let's go back and figure out, well, how did we get this formula? Well, let's take that rectangle that we had before, okay? And now, remember, a rectangle was base times height, right? Which is right here. So this part right here is really a rectangle. Okay? And so, well, how do we get the 1/2? Well, if you take your rectangle and you divide it by 2, you will get 2 triangles. So that's how we come up with the formula. Base times height and divide it by 2, you're going to get a triangle. So that half of the rectangle is a triangle. Okay, now let's look at one more triangle here, because they don't always look like rectangles. Sometimes they look like this. And of course the base would be on the bottom. That's easy. But remember, you cannot use a leaning height. So you can't use this side and you can't use that side. So no leaning heights. So what are you going to do? Well, you're going to have to find that height right down through the top, right into the midpoint of your base. And now this is going to be your straight up and down height. These are both going to be 90-degree angles. And so this is your height. So you're going to have base times height, and you're going to divide it by 2, and that will give you the area of that triangle. All right, folks, I think you're pretty much ready to do your next assignment. Be looking for that very soon. All right, oh, and don't forget, so let's put some numbers on here real quick. So let's say this height is 8 and this base is 6. So this would be 1/2 times 8 times 6. Well, 1/2 times 8 is 4, and 4 times 6 is 24, and we'll make these inches squared again. Or we could have said the base is 6, the height is 8. We're going to divide that by 2, so 6 times 8 is 48, and 48 divided by 2 is 24 inches squared. Same answer. Either way, same thing. All right, now one thing that I didn't do on this notes page that I think you always should do is I think you should always carry this A with you the entire time, all the way through, so that you know what you're solving for. Because sometimes you're going to be solving for one of the dimensions. You might be solving for the base, or you might be solving for the height. Okay, in this case, we solve for the area every time. But that's not always the case. Remember, whenever we're doing equations, we can always substitute what we know and solve for what we don't know. So that's why if you know how to do equations, you should be able to do any geometry formula that I give you. Just substitute what you know and solve for the variable that you don't know. All right, so that is our next lesson on area. And if you have any questions, you know how you can get a hold of me. Keep up the good work. You're doing amazing, this distance learning, and hopefully we'll get to see you very soon. Stay safe, y'all. Bye.